Welcome to the Mestre Nova or MNova video tutorial.
MNova is a multi-platform software used for visualization, processing, and analysis of NMR data. This software is designed to support the needs of chemists like you.
In this video, we will go through the installation process, as well as a step-by-step instruction for the basic processing of NMR data.
Once you feel comfortable with the basics of NMR processing, feel free to explore the software for more advanced features.
First, start by visiting the library's Chemistry at UTSC website, which is found by going to uoft.me/UTSC Chemistry Resources. This website contains useful information about the installation of chemistry programs, as well as the locations of campus computers equipped with this software. The MNova software is available free to all registered students, faculty, and staff at or affiliated with the University of Toronto. You must be on campus to download and activate the software and license, but after you have completed this process, it can be used off campus. On this website, under the subheading NMR Processing Software, there will be a link to MNova. Clicking this link will bring you to the University of Toronto's Mestre Nova NMR Processing Software page. You will see several licenses on this page. You will only require the NMR processing license. Click the link to download this license to your computer. You will need to import it later.
Next, scroll down the page and click the link to download the software. You will notice on the download site that there are versions available for Mac, Windows, and various Linux operating systems. Make sure you choose the correct one for your operating system. Once the installation process is completed and you start the software for the first time, you will be prompted for a license. Click the option that you already have a license and then select the license file that you downloaded earlier. Once the license is successfully installed, you can close the registration wizard and restart the program. Remember, you will need to be on campus to activate the software. The software needs to be activated once every 90 days when you're connected to a U of T network. After downloading MNova, there are a few important things to prepare before we get started on analyzing the NMR spectrum. Number 1. Download the NMR file folder that you wish to analyze in a designated folder from your course webpage. Number 2. Download the Fulmer et al. Paper, NMR Chemical Shifts of Trace Impurities with the DOI 10.1021/OM100106E. Number 3. Draw the structure of your desired compound using the ChemBioDraw software and paste it on a Microsoft Word document. Once you have done all 3 steps, you are ready to obtain your NMR spectrum for analysis.
Open the MNova program and you will arrive at a blank document. To obtain your raw NMR file, go to File, Open, and browse for the NMR file folder you downloaded from your course webpage. Once you open this folder, you will see a series of numbered folders corresponding to individual sets of raw NMR data obtained from your experiment. Disregard the 9888 and the 9999 folders, as these folders are just for calibration purposes of the instrument. To track the contents of these numbered folders, Visit Dr. Ronald Soong's NMR status blog, which is found by going to the website individual.utoronto.ca/rsoong. The numbers correspond to the experiment number, and the title gives you information about the sample, including the name of the compound and the melting point. This blog gives you very important information to help you select your data without having to go through the trouble of looking through each folder.
When selecting a set of raw NMR data, an important thing to keep in mind is that you are likely using data from your peers, since not everyone gets the opportunity to run NMRs on their samples. The idea is to select the NMR spectrum of a compound with the melting point that is closest to yours and critically analyze the NMR spectrum as if it is your actual data. Melting point is a good indication of purity of a compound, and this information is generally indicated in the title. After you open the file that you have selected, you will see a list of contents, and the file that we are interested in is the FID file. Open this FID file and you will see an NMR spectrum appear in your MNova document. Use the Zoom In button to take a closer look at the spectrum and pick the peaks individually using the Peak by Peak option under the Peak Picking menu. Once you have selected Peak by Peak, simply click on the peaks and you will notice that the chemical shift is marked in blue near the top of your spectrum after you have picked the peak. Use the Increase Intensity tool if the peaks are hard to see. Do not be tempted to use the automatic option to do the peak picking because it will pick all the peaks in the entire spectrum. If there is an aromatic ring in your compound, the aromatic region near 7 ppm will likely contain many peaks. You only want to be picking the main prominent peaks in your spectrum for analysis. To undo picking, simply click the peak again with the peak picking cursor, and the marked chemical shift will be removed.
To reference your solvent peak, check to see what solvent you use to run the NMR sample. This information is generally given in the title of the spectra on the top left-hand corner. The solvent used is often followed by U_1D_1H_organic_setup CDCl3 in the title. In this example, deuterated chloroform, or CDCl3, is the solvent. Using the NMR chemical shifts of trace impurities paper, check for the solvent residual signal for CDCl3, which is 7.26 ppm. Going back to the MNova program, peak pick the singlet at approximately 7.26 ppm if you have not already. You will notice that the chemical shift is not accurate. With this example, it is at 7.287 ppm. You will need to reference this solvent peak by putting your cursor near the solvent peak and right-clicking for the menu to select Reference. Click on the solvent peak and the reference along F1 window should appear. Enter the solvent residual signal of 7.26 ppm in the New Shift text box. Depending on which solvent was used to run the NMR sample, you may have a TMS peak. After referencing your solvent peak, the TMS peak should be automatically in sync to 0 ppm.
While analyzing your NMR spectra, it is important for you to consider possible sources of protons that can produce a signal before doing the integrations and peak assignments for the protons in your compound. Solvents used in your reaction and purification procedure, such as methanol, ethanol, and water, as well as impurities including grease, can all produce unique signals. Consult the NMR chemical shifts of trace impurities paper to look for solvent residual signals for possible traces of solvents in your NMR sample, and label those peaks with their respective solvents. To label peaks, select Text in the Annotate menu.
Integration values give valuable information regarding the relative number of chemically distinct hydrogens that can be found. To obtain these integration values, use the Zoom In button to take a closer look at the spectrum and integrate the peaks individually using the manual option under the Integration menu. Once you have selected the manual option, simply highlight the peak you wish to integrate. You will notice the integration value in blue along the green bar stretching across the base of the peak. You only want to be integrating the main prominent peaks in your spectrum for analysis. Integrations for peaks that belong to solvents are not necessary. To undo an integration of a peak, simply click on the green bar at the base of the peak and right-click for the menu to select Delete Integral. Make sure you do not select Delete, as this will remove your entire NMR spectra from the document.
After doing the integrations for your peaks, you may notice the sum of the integration values are much larger than the theoretical value. What you will need to do is to correct the integral for one of the peaks in your compound as a point of reference. For example, in the compound shown, a good point of reference would be the 5 aromatic hydrogens on the benzyl substituent. The aromatic hydrogens are easy to identify with the chemical shift at approximately 7 ppm. To correct the integral, simply click on the green bar at the base of the specific peak you would like to correct. Right-click for the menu to select Edit Integral. The Integral Manager window should appear. Enter the correct number of hydrogens in the Normalize text box and press the Enter key. In our example, we will enter 5 for the aromatic hydrogens. All the integration values of the rest of the peaks in your spectrum should now be referenced to this integral. Always remember to correct the integral for your NMR spectra because it gives you very important information that helps you determine whether you successfully synthesized your desired compound.
Coupling constants, or J values, measured in Hertz, is a measure of the interaction between a pair of protons and provides information to determine whether the observed splitting pattern is first order. To determine the coupling constants, we must first convert the units of the peak labels from parts per million to hertz. Right-click on the spectrum and select Properties, and then select Peaks in the menu. In the Units drop-down menu, change the units from ppm to hertz. Once the units have been changed, you can now calculate the coupling constants simply by subtracting the values in blue. Automatic options are available to calculate coupling constants. However, they may not be accurate, so do not rely on them. It is always best to use your own chemistry knowledge and think critically about the splitting patterns and spin-spin interactions of protons.
Proton assignments should be done after you have completed the following steps: peak-by-peak picking, reference-specific solvent peak, identify and label traces of solvents and impurities, manual integration and correction of the integral, and calculate coupling constants or J values. Completing these necessary steps will give you the information you need for proton assignments to determine whether you have successfully synthesized the desired compound. The first step is to assign the peaks in your NMR spectrum by letters or numbers from upfield to downfield, or vice versa, as long as you are consistent. The next step is to draw your compound on ChemBioDraw and paste it on a Microsoft Word document. Copy the structure from Microsoft Word and paste it on your MNova document. Do not copy and paste the structure from ChemBioDraw directly to your MNova document. The MNova software will show all the carbons in your compound as numbers, which makes the proton assignment very confusing.
Once you have successfully pasted the structure of the compound on your MNova document, label the protons on your structure by selecting Text in the Annotate menu. The proton NMR predictions from ChemBioDraw can help you determine the proton assignments, but do not rely on ChemBioDraw as their predictions are not always accurate, and we highly recommend that you use your chemistry knowledge of multiplicity and splitting patterns. When analyzing your NMR spectra, you may find many unidentifiable peaks that do not belong to your compound. If this is the case, you may want to consider looking at characteristic peaks of reaction intermediates and possible side products that may potentially be formed in the reaction. Being able to explain and justify your data is where the real chemistry comes in. The complete processed NMR spectrum should be similar to this example.
Consulting an empirical article from the Journal of the American Chemical Society is always a good way to determine how to format the data for your lab report. First, indicate the type of spectra you are analyzing. In this case, we have proton NMR. Then indicate the solvent used to run the NMR sample in parentheses, followed by a colon and a delta symbol, which stands for chemical shift. Then list the chemical shift values from upfield to downfield with multiplicity, coupling constant, and the number of protons in parentheses.
NMR spectra are generally included as supplementary material at the end of the report. Exporting your MNova document to a PDF file will best preserve the clarity of your spectra. Prior to exporting your spectrum, you may want to consider removing the title in the top left-hand corner if it appears to be overlapping peak labels. Simply right-click the spectrum and select Properties. Click the Common tab and uncheck the title box. Then click Apply, and the title will be removed. Finally, export the spectrum to a PDF file by clicking File, Export to PDF. You may want to zoom in and export your spectrum in portions so your reader will be able to clearly see the splitting patterns of your peaks. Thank you for watching this video tutorial. We hope that it has helped you in understanding the MNova software.
This software may seem very overwhelming at first, but with some practice, you will be able to analyze your NMRs quickly and efficiently.
Remember, processing the NMR is not the challenge. It is being able to justify and explain your data that will make you a critical chemist.
This video only covers the basic functions of MNova, so feel free to explore the software to learn more. Thank you and good luck.